So welcome everyone. So this is Statics of Rigid Body, and I will be your instructor for this course. Basically, this one is just an application of the physics, no? So meron na kayong physics nung nakaraan, so dadagdagan lang natin, and we will employ most of the engineering problems on this one. Okay, so also for those who have the RPL, you already have the module with yourself, and for the AOL and for the SL, so we will discuss here. Okay, so first, duration for the first chapter, so we will be having here for 6 hours, or that is for around 2 weeks. Okay, and then I am expected at the end of this chapter, you will be able to differentiate different branches of mechanics and its application to engineering problems. You will be able to identify different fundamental properties of vectors and its applications in solving engineering mechanics problem. To acquire skill in presenting vector quantities in three-dimensional and plane using its component, and to be familiarized with the vector operations and its application in solving engineering mechanics problem. Okay, and you will be having a three-dimensional or space system. So in your physics, maybe you employ only a two-dimensional, so only the x and then y, but for this one you will be able to employ it using the three-dimensional x, y, and then z. Okay, so ito pwede nyo sagutan kung kaya nyo, so ano yung alam nyo na as of now. Okay, but I'm expecting after we have discussed the first module, you will be able to solve these problems. Okay, now, so let's proceed with the introduction, no? So ano ba yung engineering mechanics? So actually, it is just one of the fundamental topics in taking civil engineering. Okay, so also if you are a mechanical engineering student, so both, kasi si mechanical at saka si civil, when it comes to the statics, they have almost common. Okay, they have the common topics. Okay, learning concept in statics will guide students in higher design subjects. Hence, it is necessary to begin with a brief exposition of the terms in engineering mechanics. So, una, si physics. Okay, so physics is the science which studies the relation of matter and energy, while engineering is the application of mathematical concepts and physics to design various structures in civil engineering field. Okay, so this one is for the civil engineering, but of course for the mechanical engineering, it is also used for the design of your different structures. So mga pipes, I guess it is the piping department. Meron kami nun before sa Chiyoda, and the piping department, and it's mechanical engineering ang gumagawa. Okay, so design is the key term that differentiates scientists from engineers, no? So si scientist, siya yung nag-a-apply ng knowledge, pero yung knowledge nun, ang nag-a-apply nun sa real world is the engineer. Okay, so engineering design is the process of devising a system, component, and process to meet desired needs. Okay, and engineer is different from engineering technologists. So baka may marinig kayo doon, may mga engineering technologists, no? So according to the PRC, the last time we have meeting sa kanila, pag sinabi natin engineer, okay, engineering technologist, okay, they solve the problem, a certain problem, on a certain scope. Ibig sabihin may limit. For example, let's say pagwe-weld, okay, so kaya nilang solusyonan yung isang bagay, pero they are bounded by the limits. Okay, magagawa niyo yun provided na ito yung standard, they already have the standard. Okay, pero si engineer, okay, limitless. Ibig sabihin, pag naiba na yung system, pag naiba na yung gagawin mo, si engineering technologist, hindi na niya kayang solusyonan yon. Pero si engineer, since you have the knowledge of the principles, kaya mo yung gawin. Okay, so that is what expected to the engineers. So we solve the problems. So we are the problem solvers. And mechanics is actually the branch of physics that considers the applied force on the bodies or fluid which are at rest or in uniform motion. Okay, so ang pag-aaralan natin dito is lahat lang ng rigid bodies. Okay, when I say rigid bodies, ibig sabihin we do not consider the deformation. Example, kapag malambot yung isang bagay at nilagyan mo ng force, technically magde-deform yan. Okay? So that is another concern. That is deformable bodies. Pero tayo dito, hindi natin nagko-consider yung mga bagay na yan. Okay? And although mechanics, okay, it is a general both on the rigid bodies and then on the deformable bodies. Kumbaga siya pinakataas. Okay? So meron lang siyang mga branch. Okay? So kumbaga siya yung mother. Okay? Aside from the rigid bodies, okay, tinatawag din natin mechanics, also the branch is kapag nagkaroon na tayo ng forces sa tubig. Okay? So fluid mechanics naman yung tinatawag. So it means the mechanics is a general branch of physics that considers the applied force and also it's either at rest or in uniform motion. Okay? So, ayan. Si mechanics is further divided into two. So, we have here statics and then dynamics. Okay? So, dyan papasok ngayon si statics and then si dynamics. In your physics class, you might have encountered problems in mechanics. Okay? Ang tawag natin is mechanics, pero normally it is statics and then you have here the dynamics. Lahat ng gumagalaw na hindi uniform yung motion. Okay, when I say not uniform yung motion, ibig sabihin may acceleration. From rest, biglang gumalaw, o kaya may speed na 75 kph, biglang bumagal, o kaya bumilis, and that is called a non-uniform motion. So lahat yon is tinatakal natin when it comes to dynamics. But for now, ang i-consider lang natin, lahat lang ng body at rest. Okay, ibig sabihin hindi gumagalaw. Okay, so the primary objective of engineering mechanics is to introduce the application of mechanics in solving and designing various aspects of structural design, and also of course component for the mechanical engineers, no? So core knowledge required in this subject. A lot of principles will be encountered by studying engineering and mechanics. Kailangan critical thinking. Okay? So, sa pagsasolve naman, gaya ng turo sa atin dati pa man, so, meron tayong given. So, we should determine yung mga given. And sometimes, hindi ibibigay ng exactly word yung mga given, no? So, iyon yung kailangan natin ng analytical thinking. Kasi minsan, okay, let's say, sinabi, I have a lot, 100 meter square. Okay? So, ibig sabihin, iba yun sa 100 square meter and 100 meter square. Okay? So, ibig sabihin, so kapag ganon, walang binanggit kung anong klaseng lot siya. Pero alam natin, it is a squarish, okay, or a square. Okay? So, those are sometimes that we need to have the analytical thinking. And most of the time, yung analytical thinking natin is nahahasa siya. Okay? Hindi sa pakikinig, no? So, you try to solve as much as possible, as many as you can. So, may binigay naman akong mga references, napakaraming tanong doon. Okay, so you may try to solve it hanggang manawa kayo. Okay, and then dapat alamin ano ba yung hinahanap doon sa problem. Okay, and then you try to have the solution. For the validation, sometimes maraming methods sa engineering, no? So I will not, lalo na sa mga exams, so I will not limit you to what I teach. Okay? So kung may na-discover kayong bagong ways or kung meron kayong sarili nyong solution, as long as it is mathematically correct and also wala kang bina-violate na principles, theorems sa physics, I would accept that. Okay? So, but basically, kapag may nakita akong mali or hindi pwede, kumbaga nagkataon lang na on that case or on that scenario, tumama yung sagot mo, okay, kasi merong isang na-neglect na principle, bibigyan ko pa rin naman ng score. Kaya lang medyo maliit, ibig sabihin there's something wrong. And of course, I will try to explain to you bakit ganun. Okay? So, punta tayo sa history and development of engineering mechanics. So, yung dapat sisihin natin, napakarami nating naaral ngayon. Then, joke lang. Okay? It was Sir Isaac Newton who is considered as the pioneer in the study of mechanics. So, nagkaroon siya ng isang book. It's called the Principia. Okay? Or the Mathematical Principles of Natural Philosophy. It deals more on celestial mechanics. No? So, kumbaga, hindi naman talaga yun on the earth. Okay? Pero kasi yung ginawa niya, it is kumbaga fundamental, kumbaga idea. Parang gano'n, no? Eh gano'n naman sa field natin, no? Pag meron kang idea, okay, and then magba-branch out na yung iba't ibang ideas, okay? And then kapag nag-branch out yun, of course, parang ikaw pa rin yung pioneer. Kumbaga ikaw yung nagsimula, no? Same with Isaac Newton. Sir Isaac Newton, siya yung nagsimula, okay? And then his work is influenced other branches of mechanics like relativistic and quantum mechanics. Kung narinig nyo na yung mga quantum mechanics, we will not further elaborate the two, okay? So, yung pinakakilala sa atin, we have the three laws of motion, no? So, we have the law of inertia, the law of acceleration, and then the law of interaction. Ano sinasabi ng law of inertia? Si law of inertia, sa madaling salita, hindi kikilos yung isang bagay unless walang tumutulak sa kanya. Okay? So, parang ganon. So, sa law of acceleration, sabi niya, yung paggalaw ng isang bagay nakadepende, una, okay, sa lakas ng force na tumutulak sa kanya at saka sa bigat. So, basically, sabi niya, yung acceleration mo, o yung bilis ng pag-usad mo kapag tinulak ka, mas mabilis yung galaw mo kapag mas malakas yung force. Okay? And then, when it comes to mass, syempre, no? Kapag malakas yung force, pero mabigat ka, mahina rin yung paggalaw, no? Sabi niya, mentrans magaan yung bagay na tinutulak, mas mabilis yung paggalaw. So, which is very, sabihin na natin, common sense. Pero it was Sir Isaac Newton who formulated that proportionality. Okay? So, yun yung F equals to MA. Sinabi naman niya sa law of interaction, okay, lahat ng bagay, basta nagkaroon ka ng force, merong kabaliktaran. Okay? So, ibig sabihin, may equal force but in opposite para magkaroon ng equilibrium. Okay? Kasi kapag walang equilibrium, yung tawag natin doon is unbalanced force. So, magi-start ka ng mag-move. Okay? So, sa engineering statics, we will employ much of the two quantities we have called the vector and then the scalar. You already, I guess, you already have the idea on the scalar quantity. So, scalar quantity, it is just a unit without a direction. So, yun lang naman, no? Example, mga mass, kilograms, grams. Pero kapag ginawa na natin siyang force, i-multiply natin siya sa force ng gravity, sa acceleration ng gravity. Okay? So, those are types of the scalar and then the vector. Example more, we have the speed. So, yung speed, it's just meter per second. Pero kapag ginawa na natin siyang velocity, so meron na siyang direction. Meter per second to the right, to the left, etc. Okay? As long as it is as a dimension, it is as vector quantity. Okay? This scalar, madali, no? Kumbaga, madali siyang ipag-add. Okay? Halimbawa, meron akong dalawang mass, 5 kilograms and 5 kilograms. Pag samahin mo, that's just 10 kilograms. Pero kapag vector na siya, hindi mo na siya pwedeng ipag-add basta-basta, no? So, we will be having a topics on the vector operations. So, kaya sa tinawag na operations kasi depende kung ano yung ginagawa natin. So, syempre, meron tayong addition, subtraction, multiplication, division. Okay? So, we will employ on that soon. Okay? Pero ngayon, magkaroon tayo muna ng tawag natin dito. Magkaroon muna tayo ng notations, no? So, para magkaliwanagan tayo. Iba't ibang book kasi, iba't iba yung notation. Okay? Lalo na when it comes to the vector. Okay? So, all throughout the modules natin, so, i-represent natin yung vector ng capital. Okay? Pero kapag nagdi-discuss ako, okay? For example, I will try to draw. Pag nagdi-discuss ako, okay? Kapag sinabi kong vector, kuwari vector A, kasi hindi nyo malalaman kung ano ako kung nakabold, no? Lalagyan ko ng arrow sa taas to indicate that this is a vector quantity. Okay? So, malinaw yun, ha? So, other books, ginagawa nila, parang may kuwit na ganun. Okay? Basta parang merong, tawag dito, notation sa taas. So, you will be having their vector quantity. Okay? So again, sa module, capital letters or bold letters are vector quantity, and while we are discussion, we will employ the arrow. Okay? So kapag walang arrow o kaya hindi siya bold letters, and then that is a scalar quantity. Okay? So ayan, bar on top, no? So while magnitude, which is a magnitude of the vector, which is a scalar quantity, so ayan, simply A, or ayan nakalagay, no? Simply A, o kaya Nakaganyan. Okay? So that's it. So kapag ganyan ang symbol natin, that is a scalar quantity. Okay? So any vector could be represented by a geometric ray plotted in two-dimensional Cartesian or three-dimensional space system. Okay, so we will go on that soon. So for now, so alam natin yung difference ng scalar and then the vector, both in principles and also on our discussion. So we will be having here the symbols bold letters or just simply a letter itself. Okay? So ito, graphical representation. So dati nag-ano na kayo, no? Lalo na usong-uso dati sa physics is yung mga displacement. Okay, so you have there the vectors, tapos ipa-plot mo siya, i-drawing mo. So kasama dapat mahalaga yung kanyang symbol. Okay, yung kanyang degree or angle of inclination, ano? Okay, so pag-drawing natin, paano natin siya dinodrawing? So basically, nagke-create tayo ng isang Cartesian plane. Doon mag-originate yung ating tail, and then yung head natin ituturo natin, pero dapat depende sa given from the horizontal, from the vertical axis, etc. Okay, so napakahalaga ng position dun sa ating vector. Okay, so ayan, punta tayo sa equivalence ng two vectors. So two vectors are said to be equal if both of their magnitudes or directions are the same. So kapag parehas na parehas yung magnitude mo, pati yung direction mo, and then they are equal vectors. Ganun lang kasimple. Now, if a scalar quantity is multiplied by a vector quantity, the resulting quantity is said to be vector, with the magnitude equal to the product of the scalar quantity and the magnitude of vector quantity, while its direction follows the path of the quantity. Okay, paano yun? Example, itong force ko na to, okay, so let's say that is 30 degrees. Technically, this is a vector quantity, no? So, meron, let's say, 5 Newton. Okay? Then, i-multiply ko yan by scalar quantity. Sabi niya, paki-multiply mo yan by 5 kasi 5 beses. So, 5. Okay, and this is a scalar quantity. So, sample, that is a scalar quantity. So, yung resulting kapag pinag-multiply silang dalawa, ang gagawin mo lang daw, i-multiply mo lang yung kanilang magnitude. So, 5 times 5. So, basically, it would become 25 Newton. Kaya lang, yung susundin mong direction is yung direction pa rin ng inyong vector. Okay? So, it means scalar multiplied by vector is a vector quantity. Okay? So again, the magnitude is the product of the magnitude of the two, and then the direction follows the path of the vector quantity. Okay? So ito, sample. So let's say n is a scalar quantity and a is a vector quantity. Their product could be as follows. Una, if n is positive, ibig sabihin kapag yung scalar natin is positive and then the product is na, yung parang ginawa natin. So it means this 25 is along this direction pa rin. Okay? Kapag naman yung negative, ganun pa rin. 25 Newton siya. Kaya lang, instead na paganto, parang opposite niya. So, parang ganun, yung distance niya is around 180 degrees. No? Kabaliktaran. So, magiging ganito yung 25 Newton. Okay? So, that is for the number 2. So, if n is 0, then the resulting product is a null or zero vector. It has a zero magnitude and an arbitrary directions. Okay? So, it means 0, positive, or negative. Okay, so ganun lang kasimple when it comes to scalar multiplication. Okay, multiplication of scalar and then a vector. Alright? So next, we'll go with the vector addition. So dito tayo medyo magkakaroon ng more examples. Okay? So assuming, okay, 2 vectors lang muna tayo. Okay? So saka na tayo kapag 3 or more, ano? So we will deal first on the 2 vectors. Okay? So merong iba't ibang way ng pagsosolve nito. So I guess sa physics, nagamit nyo na rin siya. The first one is what you call the parallelogram law for addition. Okay? Ano sinasabi ni parallelogram law for addition? So let's say we have vectors A and B. So dalawa siya, A and then B. Pag pinag-add natin sila, hindi natin pwedeng ipag-add lang yung magnitude. Okay, so what we take is normally what you call the resultant. Okay, but we will still go what you call the resultant soon. Okay, so sa parallelogram, ang ginagawa natin, okay, they come from a common point. Okay, so you have there a common point, which is the origin, and then from there you draw the first vector. So you draw the vector A, and then you draw the vector B. Okay, and then ito daw dalawang vectors na to, it could be the sides of a parallelogram. Okay, so bubuuin natin yung parallelogram. So ano sabi sa parallelogram? Two sides are congruent and parallel. So ibig sabihin, kaparallel ng B, kahaba ng B. Kaparallel ng A, kahaba ng A. And then there what you call this one? Diagonal. Okay, yung diagonal starting from the common point. Okay, from the common point, iyon yung kanilang vector addition. Okay, so ito yung value ng A and then B, ayun, C. So ito na ngayon yung ating vector C, which is A plus B. Okay, so that is the parallelogram. So we will be having that on the next problems, no? Ngayon, yung parallelogram, para rin naman siyang triangular. Okay? So, it is called the triangle law. So, dito naman, ang gagawin natin, okay, kahit alin ang unahin nyo, whether it is vector A or is it vector B, wala akong pakialam. So, basta mapag-add nyo siya. As long as, for example, nagsimula ako dito, okay, and then I draw the first vector, which is my vector A. Okay? And then, pag dinrawing ko na si B, parang gagawa ako ng panibagong Cartesian plane doon sa head. Again, this is your tail. And then, this one is your head. Okay? So, doon ako gagawa sa head part ng parang isang Cartesian plane. And then, doon mag-start yung aking second vector, which is the vector B, which is to the right. Okay? And then, from the tail of the first vector to the head of the second vector, iyon yung ating tinatawag na resultant, or that is the sum of the two vectors. Ito na ngayon yung C, which is A plus B. Okay? So, those two are the most common used for the law for the addition of two vectors. Okay? About the three vectors. Okay, polygon rule tayo. Okay, so parang ganun lang. Basta ang mahalaga, para siyang triangle law. Kaya lang, from a certain point, pupunta ka and then magdodraw ka ulit ng another line. And then dun na magdodrawing ng another vector, and then from the head of that resulting vector, dun naman pupunta yung inyong C. And then again, yung pinaka-sum niya, it is from the origin of the first vector hanggang dun sa head nung sa ating last vector, iyon yung ating pinaka-resulting sum. Okay? So, kaya pagdating sa polygon method, mas mahirap na siya kapag ginawa natin graphical, no? So, mayroon tayong another method na ginagawa, which is the component method when it comes to the polygon. Kapag 3 or more, mas okay nang gamitin natin yung ating coordinate, okay, yung ating component system. Pero kapag 2, okay na gamitin natin yung parallelogram and then triangular. On my part, mas nadadalian ako kasi ganun din eh. Mas okay sa akin yung triangular law. Okay, kapag two vectors. Okay? So, that is for the addition. When it comes to subtraction, okay, same thing lang yun. Para lang din yung addition. Kaya lang, ang gagawin natin, kuwari, vector A, dinrawing ko si vector A. So, I draw the vector A. So, ito yung origin ko. Okay, so dinrawing ko si vector A. And then from here, magdodrawing ulit ako ng vector B. Kaya lang, since it is a negative or minus subtraction, ang gagawin ko, babaliktarin ko yung aking vector B ng direction. So instead na to the right, magiging to the left na siya. And then again, yung ating sum is from the tail of the first vector to the head of the last vector, and then that would be your sum. Okay? So kapag nakakita kayo ng minus, ang ginagawa lang naman natin doon, okay, binabago natin yung direction. Okay? So kabaliktaran ng direction. Okay, so that is for the subtraction of the vectors. Okay. Most of the time, if we are going to have the triangle law, kailangan kabisado natin yung line law of sine and then the cosine law, or the sine law and then the cosine law. Okay, so ito, napaka-elementary na sa atin ito, no? So, I am expecting by now, nasa dugo nyo na ang law of cosine at ang law of sine. Okay? Now, that is for the highlight of the mechanics and then the vector addition. We will proceed with the sample problems on this part.